Hello everyone, my name is Mr. Quraish and today we are looking at science. What is science? Let us first of all understand that we are looking at the nature of science, what science is all about. So the big question is, what is science? I checked the dictionary and this is the definition I got here. The intellectual and the practical activity encompassing the systematic study of the structure and behavior of the physical and the natural world through observation and experiment. It may sound very big, but actually it's telling us that science is simply things we learn by observing our physical and the natural world. So in this lesson, we are hoping that by the time we finish it, you should be able to give a definition for science. You should be able to identify the major branches of science. You should be able to name some scientists and say what discoveries that they have made. You should be able to carry out investigations and show familiarity with some common apparatus. You should be able to name some apparatus that we need in the science laboratory. You should appreciate the skills that are needed in science. As I said before, we have often wondered about all the many things that go on in and around us. We try to find answers to what, how, and why things happen. For example, what are these things? Why are they considered living things? We are here, human beings. We have a butterfly, we have a friend here, the dog. We have plants, and then we have some that are even very small. We can't see with our naked eye, but they are considered living things. Why is that? How do they carry on their activities? And on the other hand, we have things we consider non-living. And why are these ones non-living? What makes them to be grouped in this group where we say they are non-living? We sometimes are curious about things we can see, things we cannot see, events that amaze us, or sometimes they even terrify us. It makes us to be very afraid. The answer to all this question is, science. So we come back to our question. What is science? Remember the definition we're looking at, I said is very bulky. We can make it very simple here. Science is simply an answer. Science is the knowledge that we get when we ask questions. So like we said, it's an answer to the questions we ask. We want to know what, how, and why things are what they are. And by studying science, we get knowledge to those things. Science is also the knowledge we gain through experience. Experience in this sense, something happens or you do something or you go through something. The knowledge you get from that is also science. Science is also the facts or principles gained by systemic study. So examples of some things we want to know which science can help us explain include take a look at the picture, look at the pencil. So why does the pencil appear bent in a glass of water? When you place it in the glass without the water, it is straight. When you place it in a glass of water, it is bent. Why is that? Why is it that anything you throw up in the air falls to the ground? Why doesn't it continue going up? I also may want to ask, if you have a balloon, you put water in the balloon, and when you leave it, where is it going to go? Down. But if you put air into the balloon, and when you leave it, it goes up. Again, the scientists will want to know, why is that? How are babies made? Interesting question. We see babies all the time. How are they made? These are all questions that go on in the minds of a scientist, especially young scientists, young children like you. You want to know answers to all these things, and yeah, we're going to provide all the answers. So the answers to all these questions lie in science. So if we continue to study science, we're going to know a lot. But there's too much because science is about everything that goes on in the world. So the body of knowledge is rather too large for us to study everything. So we divide them into branches, into tiny bits that we can comfortably handle and study. So let's look at the branches of science. When we say branch, like I said before, we're simply dividing all the body of knowledge into little bits. So each bit we study at a time. That's why we say systematic. So you take them a bit at a time. You don't take everything at a go. So there we have science at the head there. So there are many ways other people will want to group them, but let's say we have natural science and we have social science. Now let me start with social science. Simply, it is divided into two, sociology and economics. Sociology simply deals with people. In fact, social science itself is all about humans, okay? The way we deal with each other, the way we deal with things around us. So sociology looks at the mind, the thinking of people. Economics is about how we make and expend our incomes. The farmer going to the farm, making something that he can feed on. Let's come now to the natural science because that's our main area of interest. First, we divide it into two. We have a physical science, we have the biological science. Let me start with the biological science. That deals with living things. So we have here zoology, that deals with the study of animals. All the animals we study, we place them under zoology. And the plants, we place them under botany. Now we come to the physical science. This deals with non-living things. But of course, sometimes there are some things in our body. We are living, but there are some things in our body that are not living things. So they all fall under this physical science. It includes physics. We'll look at it later. We have chemistry. And we have the earth science. Now, let me say a bit about earth science. Is simply studying the earth, the surface, the inner structure, the core, everything that makes up the earth, including the atmosphere. We study under earth science. Again, if we look at this, it's a little bit confusing. So let's make it a bit simpler. So therefore, we say the branches of science are simply physics, chemistry, and biology. If we put them this way, it is very simple, very easy to study. So the branches of science at this level, to make the study easy, we'll simply say it's physics, chemistry, and biology. Let us see how each of these branches are involved in preparing and drinking sorrel juice, or wonjo as we say it in the Gambia. I'm sure everybody knows wonjo, but quite a good number of people will know how to prepare it. But some of us, no idea how it is prepared, but what we know and what we're good at is drinking the wonjo juice. So physics is concerned with energy with which the sorrel leaves are boiled. Heat that we get either by using a cooking gas or maybe firewood or charcoal provides heat, and that heat boils the water, and in doing so, the sorrel leaves, whatever material is in the leaves are extracted by the heat of the water. Physics is also concerned about the force and motion involved while steering the wonjo or the sorrel leaves. And as it is boiling, you need to steer it, because by steering, that makes more of the content to be extracted from the leaves. Chemistry, on the other hand, deals with the reaction between two or more types of matter to form a new type of matter. Okay, here nothing new is formed. All we're doing is trying to get the content from the leaves. You can already see the wonjo is already forming. So the chemistry is about what is this material made of? What and what came together? What did the plant put together to make the material that we enjoy in the wonju? Biology, on the other hand, is concerned about what do we get from this wonju when we drink the wonju. What useful matter from the juice is going to help the body to grow, because it is going to incorporate or add it to our body. So what will wonju do to our body? That's biology. Biology is also concerned with all the living matter in the universe, like plants, animals, the microorganisms, and how all these organisms are interrelated, how one depends on the other. Without one, the other cannot survive. If you take one out, all the others are going to experience some problems. We can also look at science and divide it into two main groups. One that deals with the what, the how, and the why. Like we said earlier, we ask a lot of questions. What is that? How does this happen? And why does it happen? That branch of science is known as the basic science. It simply answers all the questions we have about what is happening, why it is happening, and how it is happening. The other bit is called applied science. What is applied science? Applied science is simply when we use what we know from what we know about basic science. Because basic science is about knowing something. What is, the answers you get from what is something, okay? What is this? Or how is wonju made? Why is it red? So all those answers you have, you now use them, you apply them, and when you do that, you now have applied science. So again, you can see science is a very big, it's a broad knowledge, but we can break them into pieces. Earlier on, you saw so many branches, which we brought on the 3 groups, and now we're bringing them into 2 simple groups. So, in order to work better or to make our study organized, we use what we call the scientific methods. Now, this helps us to deal with basic science. Scientists have an organized and orderly way of working. And that organized and orderly way of working is referred to as the scientific methods. It is a method that is used to find answers to questions about the world around us. There are several versions of the scientific method. Some versions have more steps, while others have only a few steps. And we're going to take a sample of the ones that have only a few steps. So let us understand the scientific method is simply a method that has been designed by scientists so that they can have organized and orderly way of doing things. So you can see I've made 4 little boxes here. And again, to remind you that the scientific method helps us to deal with basic science, because we want to answer what, how, and why things are what they are. So, first step is identification of the problem. What do we mean here? What do you want to know, or what do you want to explain? You need to use observations you have made to write a question that addresses the problem or topic you want to investigate. So, if there is a problem, you have questions like, what happened? How did it happen? Why? And what is wrong with something? I give an example of a flashlight. If you have a flashlight and you switch it on and it doesn't come on, then you have a problem. So you need to identify the problem with the flashlight. And your next step is, so you ask questions so that that will help you identify the problem with your flashlight. What is wrong with this? And next step is you form hypothesis. Hypothesis is simply making an intelligent guess. What do you think would happen? Predict the answer to your question or the outcome of the experiment. So you are saying, okay, my flashlight, maybe I didn't place the batteries the right way. Maybe the positive, which should be followed by the negative, is the other way around. Maybe I put both positives together. Or maybe the battery is, finished. Or is the light bulb working properly? So those are guesses you're making, but they have to be intelligent guesses. And those intelligent guesses, we call them hypotheses. So you try to form a hypothesis so that you can find answers to the questions you are asking. This is just to help you predict what is going to happen. Next, the hypothesis you're making or the assumption you're making will help you, plan ahead and say, okay, if I now test or do this, which is, let's say you create an experiment, you have to design something. How will you test your hypothesis? You need to develop a procedure for reliable experiment and address safety rules. So while you're working with something, some situations, things are dangerous, so you have to take precaution. You have to put down how or what you're going to do so that while you're doing your experiment, you will enjoy yourself. If you're dealing with something that can easily catch fire, what would you do so that the fire doesn't grow out of control or the fire does not get you burned? If it is something that explodes, what do you do to protect your eyes so that you carry on your experiment and there will not be any injury to your eye or you will not have any burns to your hands and fingers? So do you wear gloves and so on? So the next step is to perform the experiment that you have designed, that you have created. You follow the steps in the procedure to perform the experiment. What you've written down to say, okay, my flashlight is not working. What could be wrong? Let me check if I observe the polarity, that is, the positive and the negatives are aligned the right way, or you test to see if the battery, maybe the battery is finished, or is it a light bulb that is broken, is no longer working? So you perform the actual experiment. Remove the batteries, test to see if you now change the way they are placed. If it works, okay, your problem is solved. If it doesn't, you have to try another test, which is replace the batteries with new ones and see if they work. If it still doesn't work, you now have to check the light bulbs. Is the light bulb a good one, or is it already broken or damaged? If it is not, if it is, okay. If it is not, you have to go to the next step. The flashlight as a whole are things connected the right way. So after performing all those experiments, you record that as an experimentation or verification, confirming that this thing I'm having, these are the steps I took. And finally, you come to what we call analysis or conclusion. Is the data reliable? The information you've collected, are they something you can trust? Are they something you can work with? Do your data and observation from the experiment support your hypothesis? You said maybe I didn't line up the batteries the right way. And maybe the battery is finished. So the information you got from the experiment, did they support this work? If the answer to that is yes, then you write what we call a conclusion. You're going to say, this was the problem, this was what I predicted, and this is the answer I got. So that's is your conclusion, or it summarizes important parts of your experiment and the results. If, on the other hand, the answer is no, then you have to change or modify your experiment and do something else until you arrive at an answer. So that ends with your conclusion, and so we can now show you the summary of the scientific process here. We've taken 4 steps. One is asking questions. What is the wonju juice composed of? How do you make it? And then you're also looking at hypotheses and ways to say, okay, if I boil the sorrel leaves, I'm able to get the wonju juice. But what will happen if you just take the sorrel leaves and you put them in water without boiling? So you have to make your assumption or hypothesis there, and then you carry out the experiment itself. Take the leaves, put them in a pot of water, and boil for a certain time, and see what will happen. And if the juice comes out of the leaves, then you can conclude or make your conclusion that by boiling the sorrel leaves, you're able to extract the wonju juice, which now you can try to use that or come to applied science, where you can now say, okay, how can I make other juice? Other juices, right? Like lemon juice. If I take lemon fruits and I boil them, will that give me lemon juice? Or do I simply just need to cut the lemon, squeeze them, and then get the juice? And what will happen if I should add sugar or add salt? Will that improve the taste? Or will the taste or the flavor also improve if I add vinegar, for example, so as to give me better taste? So this, in summary, is a scientific method or scientific process. You ask questions and you make guess about the possible answers you can get to the questions you are asking. You perform experiments and you write down your conclusion. The scientific method or scientific process is actually what scientists use to solve a lot of problems, like making aeroplanes. Now it's very easy. If you are using aeroplane, you can move from one end of the globe to the other within a very short time. And so there was a problem before. We needed to move fast, but how can we solve that problem? Another use of the scientific method is making cars. Today we have very beautiful cars. Again, they help with transportation. We use them to make space rockets. This helps us to move not just on the Earth, but also to move away from the Earth, so we can go into space and we can go into other planetary bodies like the moon. Again, the scientists have been able to produce this using the scientific method. Computers also that have come very handy and they do a lot of work for us. They were made, again, using the scientific process. Medicines, we have a lot of illnesses, but by using the scientific method, we've been able to move away from a lot of superstition. Before now, when you're sick with certain illness and nobody knows the cure, they will assume it's bad people, or sometimes we attribute some to devils and so on. But if the scientific method is used, we ask questions, we make hypotheses, we do some experiments, and then we're able to create medicines for those things. Currently, we have the COVID that is confusing every scientist, and they're going through the scientific process, but we hope of getting a cure or maybe a vaccine that will help us to deal with the disease. Smartphones and satellites and television, all these have come into existence using the scientific method. Television really changed the world because something happening in one end of the town or world or wherever can now be viewed from the comfort of your sitting room. That is a great work of science. The light bulb that has changed the way we live now. It's very ingenious the way we came about having a light bulb, and so much more. There's quite a lot of things that scientists have been able to make using the knowledge of science and also carrying out the scientific process. So, in summary, to use the scientific method, observe, That means you study carefully and you ask questions so you can be able to look at what the problem is. You're trying to narrow down the idea of what really is wrong with whatever you're going to look at. And you hypothesize. That means you make hypotheses, you make intelligent guess as to what the problem is. And you follow it up with experiments. So the experiments confirm or verify that the guess answer you put is right or is wrong. If it is right, you have to repeat it again to be sure it is the answer to that problem. If it is wrong, then you have to try some other hypothesis. And whatever information you have as a scientist, you need to share that information. You need to share your results so other people can know that the answer to this problem is this. You don't just keep it to yourself, then it will not be beneficial to people. So we look at what a good scientist will be doing. Good scientists exhibit these traits that we've just put some of them on the board. One of them is curiosity. The good scientist wants to know how or why whatever something is, how it works, what would happen if you do this and this, if you put together, for example, sorrel leaves and hot water, what would happen? Or if you put them in cold water, would you still get the water out of it? So you're curious. How does the light bulb work? How was it made? That's curiosity. The good scientist asks a lot of questions. Whatever is around him, whatever he wants to study, he back it up with a lot of questions. A good scientist must be honest, because honesty is a very important virtue for the scientist. You don't make assumptions, and if your findings don't follow the assumption, you don't, fabricate it and mix up some false claim, because other people are equally going to test whatever you say that this is that. Somebody is going to test it. You must have an open mind. Don't be fixated to say, okay, this is what it's going to be, and it must be that. If it is not that, then the problem is not me, the problem is something else. That is not the way the scientists work. You must be ready to accept whatever outcome you get. Skepticism, meaning you should always have a doubt as to things that people say. For example, when COVID came, we're hearing lots of stories. Some people will say, if you take bitter cola, it will prevent you from having the COVID, or it will help to cure you. Now, as a scientist, you don't just take that whole article, you test it, you put it through experiments. So that's the aspect there. And also, you must be willing to be wrong. So you must have the willingness to be wrong and make mistakes. So you don't just say, whatever I'm doing must be 100% right or correct. No, sometimes you can make mistakes. So these are just some few points we're saying a good scientist must have. Traits simply mean characteristics, good attributes about you. You must be a curious person. You must be an honest somebody. You must be, open to other aspects. Don't just think that you or what you expect is the only and the right thing. But again, you must have a doubting mind as to whatever information is given. Don't just take anything that people give you. You look at it critically. Some things you say to yourself, does this make sense? That's how the scientist should be. You don't just, whatever you are told, you go with it. You must have, critical way of thinking and asking questions. And you should expect that you make mistakes and be ready to be corrected or correct yourself when those mistakes are made. So let us look at some scientists and their discoveries, their contributions to society. There are quite a lot of scientists, thousands of them, that have made impact. But we'll look at just few, not necessarily the most important, but we're just trying to look at some of them, especially the ones that have made contributions that have impacted us the most, or that we are most familiar with. First, we have Benjamin Franklin. Now, note that these scientists, a lot of them made many discoveries. Some will be making discoveries in the area of physics, chemistry, and biology, but usually there's one or two things that will make them very famous. This guy was interested in electricity. Particularly, he wanted to understand charges. Like you have charges in the cloud, and then you have thunder. When these clouds meet. So he wanted to understand more about that, and he did an experiment that some might say is a bit stupid and risky for his life, because what he did was to try to, get charges from the cloud by connecting a string to a tree, and he placed a key at one end so that when the thunder strikes, you want to see if the electricity can be taken from that tree through the string down to the key that he was having, and it happened. Luckily, he survived it. But today, we are happy to have what we call the lightning rod, because it helps us to prevent us from having the effect of thunder in our buildings. And when you have the lightning rod, you can see in the diagram, the thunder strikes, the current, the electricity is directed to the ground. So that way, the building and whoever is inside is safe. So thanks to him, we have the lightning rod that helps to protect us. Today, they're using most plugs have what they call the 3-pin plug, and you have the arc plug or the arc wire. And that idea actually came from Benjamin's contribution. So today, houses are designed or wired in such a way that there is a wire that goes down to the ground. So whenever there is thunder and lightning, that takes the extra current, or even when there are accidents in the home with electrical appliances, the extra current is sent down to the ground. So we thank him for inventing the lightning rod. There is Michael Faraday. Again, he was also an active contributor where electricity is concerned. In fact, he designed, or he was the first to produce the electric bulb, which today has made our world more lively and interesting. So his contribution is in electricity. Joseph Lister, now he came up with what we call antiseptic. Now, when you have cuts and germs, particularly bacteria, if they enter the wound of the cut, they're going to multiply, and they're going to make that wound to grow bigger, and that is going to threaten the life of that individual. So he observed, as a scientist, that when people are operated upon in theaters, or when soldiers go to war front, and a lot of them come with wounds, he observed that many people eventually die because the wounds become very rotten or very large. So by observation, he realized there were bacteria in those wounds. So he now designed something that can be used to help people clean their hands, or if there are wounds, by applying some of these chemicals that we call antiseptic. It will stop or reduce the growth of the bacteria, and thus prevent the wound from having infections. Aklilu Lima, this is an African, Ethiopian. His work was on preventing bilharzia. This is the worm that causes bilharziasis or schistosomiasis. This worm, we get them from water, and they eventually find themselves in our blood vessels, and so they damage a lot of blood vessels, and people will have blood in their stool or in their urine, and they will have other complications. They become anemic, they become very weak. So his study on that helped us to understand the life cycle of this organism, and thus how we can prevent these organisms from causing a disease that is called bilharziasis. And another African, Nana Pratt, this one is Nigerian. Now, she was concerned about the food value, what food we can get by eating certain fruits, vegetables, like cassava. If you eat cassava, what are you going to get? And how much of the food value that is there? We eat a lot of food. There are some you eat and they give you very little something, and others that you eat, they give you a lot of certain food. And when we talk about food, we're looking at the nutrients here. If you recall, there are carbohydrates, there are fats, there are proteins, vitamins, and minerals. So she did a lot of study on the value of foods that we eat, and she was able to come up with some interesting figures that has helped, particularly in Africa, so that we know which foods to go for, so that we can get very important value, especially in vegetables like cassava. And then we have Louis Pasteur. He's very famous for pasteurization, which was named after him because his name is Pasteur. So what happened was he, like Joseph Lister, they were studying microbes, microorganisms, and he was able to discover that when you have food, particularly foods like milk, after some time they go bad. What causes them to go bad? He realized bacteria was in them, and that if we can deal with those bacteria, then we'll be able to give the food a longer time to stay. So he came up with the idea of boiling milk, and that was applied to other substances, that if you bring them to near boiling, you don't exactly boil them, but you heat them so that they are near to boiling, which kills the bacteria or other germs, and then the food can stay longer. So again, Louis Pasteur invented pasteurization, which is the process of boiling food or heating food so as to kill germs and allow the food to stay longer. Today we call that preserving food. And now we can use different methods, and not just using heat, but today we can use, from scientific observation, they know you can use vinegar, or you can use lime, or something acidic. All these things kill germs. So if you place them in a container like this, and then you place your food there, you cover them up, they'll stay longer. There's Alexander Graham Bell. He invented the telephone. It might seem very simple today because telephones are everywhere. Some of you probably may not have seen this because they are gradually disappearing. This is the type of telephone, not even this type, because the time he invented telephone, it wasn't up to this level yet. But the telephone is an interesting invention because people needed to communicate, and they needed to do so very fast. But then there was no easy way for people to do that. When he came up with this invention, it saved us a lot of trouble. So now we can be able to communicate very fast. So today, if you're seeing fax, you see email, internet, and of course our smartphones and everything, the idea all started from his invention of the telephone. So we owe him to that, Alexander Graham Bell telephone. Right, next we have Gregor Mendel. His area of study was on genetics, and he helped us to understand the laws of heredity. Heredity simply is talking about the things, the traits, the characteristics we take from our parents. We all understand, even before he came, everybody knew a child will look like the father or like the mother. And in some instances, a child might be slightly different from both parents, or will have characteristics from both parents. Through his study, we were able to understand that better. Let's take a look at this picture. You have this flower that is purple, and this one that is white. Now, when they reproduce, that is when they have new plants with flowers, you can see here all of these are purple, but here half of them is purple and the other half is white. Why is that? Through his experiments and the other things, we were able to understand how we get things that we get from our parents, why we look like our parents, and it answers questions like why different colors of eyes and body and everything we experience today. Edward Jenner, his area of study was also on microorganisms, and thanks to him, today we almost have zero occurrence of smallpox. Smallpox is a very dangerous type. It's a bit similar to chickenpox, but chickenpox is not very serious. If you have smallpox, usually it causes a lot of deformities on the body, and when during its time, when it was existing, when people have contracted, whether they are children or adults, survival rate was very less. So, but through his study of microorganisms, he was able to understand what was causing the smallpox. But most importantly, he came up with this idea of vaccination. In his village, he saw that most people were having smallpox, but there was this girl that was in a farm. She was not having the smallpox. He came to understand the girl was working or taking care of cow. And at some point, this girl had cowpox, which is similar to but different from smallpox. So the scientist method, he experimented the idea, got a boy that was healthy, was not having smallpox, and he took that. When somebody else is having the smallpox, he took the liquid from the smallpox and injected it or made a cut on the boy's body and placed there the juice from or the liquid from the smallpox. The boy became a little bit sick, and then he got well, and we didn't have the full-blown smallpox. So it was from there the idea of vaccines came up. And today, of course, we're hearing about wanting to create a vaccine for COVID-19. The struggle is on. I think they've almost got some answers. 3 or 4 companies have announced they've got successful ones, and they're about to try them. So let's hope if they work, we're going to be free of COVID. It's not going to be a worry any longer. Right. So we want to look at some questions to check our understanding of what we'll be looking at today. So the first one says, below are phrases depicting various activities in science. Match each phrase to the following subjects. So let's look at this. The Speaker of National Assembly, study of plants, soap making, repairing a radio, the study of animals, study of forces and energy, living and non-living things. So on this side, we have the studies, that is the subjects. We have zoology, chemistry, politics, physical science, physics, botany, and science. So your task is to read this, and then you match them. Let me give you an example here. The Speaker of National Assembly, which of these topics would be related to that? It's definitely not zoology. If you recall in our lesson, I told you what zoology is. But the Speaker of National Assembly will be involved in politics. Politics is a social science. So I leave the rest with you so that you will look at each of them. Study of plants. Which of these tasks are you going to say is the study of plants? Next, I want you to write 4 lines of description of how a scientist behaves or how a scientist works to solve a problem. So you will say number 1, what does he do first, followed by the next step, the third step, and the 4th step. And next, these are objective questions. Here, it says, who invented the telephone? And you have these options. Thomas Alva Edison, Galileo, Alexander Graham Bell, G. Marconi. So you have to choose one, the correct one. Who developed the smallpox vaccination? Edward Jenner, Alexander Fleming, Albert Einstein. Again, you have to choose the correct one. Who of these scientists who developed the smallpox vaccination? Which of these scientists discovered that germs cause diseases? Is it Linus Pauling, Albert Einstein, Jane Goddard, Louis Pasteur? Again, you have to choose one, okay? Which of these scientists discovered that germs cause disease? Which of these scientists discovered gravity? We didn't talk about that, but you need to go and research and find out, or perhaps you already know this. Richard Feynman, Alexander Graham Bell, Isaac Newton, Thomas Edison. One of these discovered gravity. So who is the person? You need to give the correct answer. We'll end here for today, so that's the end of our lesson. I want to thank you for patiently going through our lesson. Thank you very much. Once again, my name is Mr. Gresh.